So this is our main Java class, and we are extending application abstract class that's coming from JavaFX library. And based on it, we can create our main window, our main frame with the scene and everything that is going to be happening in our game. So without further ado, let's begin with our class fields. Our class fields here, I will define just width and height, the size of the window that we are going to create. Another is the bricks level. So what it means is the levels of bricks that we're gonna have in our game. Another is the width and height of the brick. Padding. Padding means the distance between the edge of the window and the bricks themselves. And the radius of the ball, the racket dimensions, and the distance of the racket from the bottom of our window. And here we are calculating the position of our racket according to y-axis, which is the height of the window. We are subtracting the distance, which is the 20 here, and the half height of our racket. So another constants that we are gonna define are the objects of a ball, the reference to the racket themselves, which is gonna be the rectangle object coming from JavaFX, the boolean, which means if game is running or game is over. And when the game will be over, we'll show the main menu. So here is the reference to the main thread of the game. It's going to be running, the ball is going to be running on a different thread than the application itself. Here's the reference of the scene and the pane itself, which is the whole window, the whole layout that we're position everything that's going to be happening at our game. So another variables are the velocity of our ball in the X and Y axis. It means how many frames, how many pixels we want to jump on every change. And another is the thread slip. We want to how many milliseconds it will pass until another frame will render. So if we lower it, means will be re-render faster, but it might overwhelm our processor. So you need to kind of adjust it. And the rest of variables here, we have a list of our bricks that will have the reference everywhere, the number of points, and another text field that's going to show up in the corner that's going to show how many points we have basically. And here we can calculate according to the number of bricks we're going to generate the maximum score you can get in certain game. So let's begin with a start method that we inherited from our application abstract class. So we have to override it. And here in the parameters, we have a stage, which is our window itself. So for this stage, we have to create a scene where we're gonna render everything. And according to the settings, we can adjust the width and height. So first, we're gonna create our main layout where we're gonna place each element, all the elements basically create our layout. So we will start with the main application, main menu. So this we'll implement later, and here we're gonna create our main scene. And in the main scene, we'll render our layout. So we have to pass our layout, which is pane, implementing by different layouts. So we will gonna use flex layout, where you can just adjust it according to in the horizontal or vertical line, you can align your elements and pick the specific gap between them. But this we'll gonna implement later. So here we create our main scene. We are defining the width and height, and this is our style sheet where you can use CSS, but you have to remember that the syntax is different than your regular CSS that you're using in your browser. We'll get to this later. So here we just set the title of the window, we set the scene to our stage, and we invoke the method show. Here in this case I will just disabled. To show up our window, we have to invoke the launch method from application class. Another method that we're going to define is to create our main menu. So we will start with the flow pane, which is the layout that you can position, align it up to you. And I'm going to do it vertically and position all the elements in the center. So I will set up the gap between elements. This is important to set it ID, so we can relate to it in our CSS class. Another thing, it's the title of our main menu, also assign the title ID. Another is the button to start our game. I set the minimum and maximum width. And here is the event handler. On clicking on this button, we will basically create our game assign it to our game window, set the root. It will replace our main menu, set the points to 0, text field once again to 0, and create the game itself, start the main thread. Is the another logic that after you finish, you lose or win the game, we will show this menu once again. And if the counter is not null, which means you actually play the game, we will create our final text field. We'll display that you won. If not, the game is over. We set this text to text field center and show the scores that you won. And this will be passed to our root element on our layout. Or else we'll just create our regular main menu as at the beginning of our game, of our running application. So to create game, I prepare a separate method for it. So you'll create the window itself, assign the reference to our main layout. And here I will pass reference to this layout to create all the elements that will display on our window. Okay, so let's begin with our game window. It's just gonna be the pane itself. And pane doesn't align our elements automatically, so we have to set the position by ourselves. And we just assign ID to style it later on. Another is the list of elements. So we'll create ball, we'll create the rocket on the bottom, and we'll create all the bricks. Also, the counter is gonna be this text field in the corner that will show how many points we have. So let's begin with the counter. It's just a regular text field, and we get the points, assign ID, and set the corner position. Pass it as a children to our layout. Another element is the ball itself. For this we'll use a circle, we set the radius, ID, and the position. We will just position in the middle of our screen. That's going to be our starting point, and we also pass it to our elements on the layout. We are creating our rocket. So this is going to be a rectangle with ID rocket. These are dimensions, and position is going to be on the bottom of our screen in the middle of our window. The next one is the method to create bricks. So for this one, we'll assign the new array list and set the position, which is the padding. We are starting from the left our window, and then according to the size of the bricks, we'll create another elements until we will reach the padding on the other side. And then we'll create another level and until we'll reach the number of levels we want. This is the loop, and y will means that the current level we are on. So we have defined 3 levels here. So we will just invoke this method to create one brick according to the positions, add it to the root, add it to the list, and then increase our X position by another brick. And in the case when we reach our padding on the another side of the window, then we will reset our position X and add our height, which is the height of the brick itself, and increment this value, which is the level, current level. And at the end, we just calculating according to the size of this list. I just set up 15 as a points you will get by crushing one of the brick. Another method is our simple method to create one brick, which is going to be a rectangle. We are assign ID to it, dimensions, and the position. Another is to add main window event listeners. By assigning it on the key press, we are getting the event, and from event we can get the code of the key that was pressed on our keyboard. All the codes are already defined. We can just use our switch and get already defined, which is the 16 in this case, key. And what we are doing here, basically we can check in the X axis if the rocket is larger than 0, which means is on the left side of our window. If it's higher than this, then we can still move it. If it reached the boundaries, then we are not moving it basically. And here I just pass by checking it just the constant value 17 because it's moving quite fast. So I decided it's going to be 17 and we are doing it in the right direction. In the right direction, we're just checking if we reach the boundary of our right side. If not, we can still increment it. Now it's going to be the most complex method of this whole application. which is the logic of our game. And we assign synchronize because we don't want threads to manipulate the data in the same time. So we are synchronizing the access by every thread. So first, by invoking it, we'll just assign this flag to true. And here we creating the new thread class and passing our anonymous function to it. And this function, what it does in the while loop is checking if the game is still running. So now we'll define the whole logic of our ball. So we have our main thread, which is our window and everything that is happening on our window. And we have separate threads of the moving ball. So we can manipulate our ball on a different thread than the whole application is running. Okay, so first in our loop, we are gonna check if there is some collision with the walls. So what we're doing here, we're checking where is the X position of our ball. And if we reach the right boundary of our window, and we subtracting the radius because we want to stick to it, not overlapping, or is the lower of our left boundary, then we changing the direction in x-axis of our ball. Another check is on our y-axis. If our y position of the ball is less than the radius of itself, which means it's on the top of our window, then we're changing the direction that the y position of our ball is moving. So we're just basically bouncing it back down direction of our window. Another check is the collision with the rocket. And for this purpose, you can use a special method, get bounce in the parent. So we're just getting the bounce from our parent element of this specific rocket, and we check if intersect with our ball. So this is really convenient because you don't need to check the dimensions, the length of our elements, height and width. We can just check if it intersects or not. And if it does, we do what we did previously. We just bounce it back. So we just basically changing the direction, is incrementing it in y-axis. And here we want to handle, we have our rocket and the ball is coming from this direction. So if it drop on the closer part of our rocket, we want it to bounce the same way as it came on our rocket. So for this purpose, we just checking if the center, the position of our ball is in this segment of our rocket. So for this, we need the width, and we basically dividing it by 2, and we checking if it's the same direction that it came from. So in this case, then we are changing the direction of X, and this is another position when it's coming from the other side. So we need to consider those both cases. Another collision check is basically checking if we failed or not, if the game is over or not. For this purpose, we basically getting our Y position of our rocket, and if it's below, which means has higher value in Y position plus radius, so we want to check if it's below our rocket, then the game is over and it means we failed. So once again, when we detect that the ball is below our rocket, what we're gonna do, we are assign the value false. So on the next loop, we'll get out from this infinite while loop. And in the same time, we are assigning main menu, creating our new main menu and set it as a root, replacing our main layout with main menu. And the last collision check is, of course, with our bricks. We need to, there is some gameplay. So we need to check if the ball is colliding with any of the bricks that we defined previously. So this we will implement later. And at the end, we are using try catch because there might be some interruption from other threads. So just in case, we can catch any exceptions related to the thread, and we just delaying our loops. In this case, it's 30 milliseconds. And here we'll just assign the position. And the last thing we want to do in this method is to set the game running to false just in case, just to make sure that the game is over and we will not get into this infinite loop once again. The last thing that we are going to do in this method is, of course, to start our thread. So we just invoking the start method. Right, so now let's implement the logic of colliding with our bricks. So we basically looping over the list of bricks. Then we are checking, we are using super useful method that I described previously, that we just check if it intersects with the bounds of our balls. If it does, we are removing it from the list. And here is the crucial thing. By invoking the platform and run later, what we are doing, we basically not interrupting those two threads, and the run later, it means we are invoking action on our main thread of the application, which is our JavaFX, not this specific thread that we created here. So this is super important, because otherwise we would interrupt both of them and it will throw exception. So by using this platform run later, we can basically manipulate our main application. So what we are doing here, we just removing it from the list from our main layout. We adding points, and we just setting once again the new value in our text field. And here, after this loop, we are checking if the bricks are empty. And if they are, it means we won the game. So in this case, we can assign is game running to false. Then this loop is interrupted and the thread is over. And we are creating our main menu once again and setting to the main root scene. So that's basically the whole application. It's not really complex. It wasn't that hard to figure it out, thanks to those intersects method. So now what we're gonna do, we're gonna run our application, of course. So let me show you how it works. It's building a couple of minutes. So this is our game. Super simple main menu, gloss texture background. So when we click start game, this is our game. And as you can see, our collision detection is working as it's supposed to and increasing the values. So yeah, that's how it works. Not really complex, but based on this, you can figure out how threads are working. Now let me show you what's gonna happen when it will go below. The game is over. That's how it works. So one last thing. I mentioned before that for styling we are using our CSS file, and basically we are using our IDs to identify different elements. So now let me briefly show you how the structure of this file. So here is our ID of game. And what we are doing here, as you can see, the syntax is different than regular CSS that is working in the browser. So we are doing here, we're just finding the path of our image and assigning it to the background, and we stretch it to the whole window. For Racket, we just assigning, as you can see, there is no like background color. You need to use fill. You need to adjust to how JavaFX defined. We just assigning the colors in the hex. We try to make it smoother. The stroke around, which is inside our element, so it's not gonna extend the height and the width. It's gonna be more complex for logic. The ball we're doing basically the same, and the bricks. For our menu, we assign our background image as well. And for title, we just set the font family, bold, and align it in the center. For buttons, we're doing it basically the same. For buttons, we can also set the background of it, which is kind of cool. And just like in the regular CSS, you can also use the pseudo class to handle different user actions. So in this case, we'll handle when the mouse will be over this element. And in this case, we're gonna change slightly the color, our border in our button element, and increase the width and the radius of our border. So the counter has monospace, font family, and the bold and the size. So this is the CSS structure. One thing that I forgot to mention, that to create our main JavaFX application, you need a separate class. And our regular class that has this main static void method. And in this class, we'll invoke our main. So the threads are not gonna interrupt and we are not gonna get the exception. So that's gonna be all in this episode. I hope you found it useful. The source code you can find in the description of this video. See you in the next one.